Hey, I'm Winnie again. Yeah. Welcome to Facebook OCP 2-socket server Tioga Pass refresh workshop. I just get through, yeah. So last year we contributed our Tioga Pass system. Here I will go over, revisit the Tioga Pass design and from system point of view or motherboard point of view, and then I will highlight some of the key new features of this system and the possible configurations that we can go with this system. I'll take questions at last minutes. Yeah. Tioga Pass is Facebook general purpose 2-socket server. And it has a higher performance over the previous generation Leopard. We do modular design, so we can have a different kind of configurations. I will share a little bit more in detail later on. We always focus on serviceability. This server is easy to service. For example, except for the CPU and heatsink through that you may need to screwdriver to take that out. For all the other commodities that you don't need any tool, you can easily to service the major commodities like memory, hard drive, SSD, add-on card, or NIC card. You can even deassemble the system, take out the motherboard without any tool. There's only one thumb screw to lock the motherboard to the chassis. We're open. We contribute this design to OCP, and we'll also take feedback from the community to improve our design continuously. So here is the high-level spec of this server. It's our latest generation 2-socket server with Intel Skylake CPU. We support up to 165 watt CPU. The system has total 12 memory channels that we have two motherboard SKU, single-sided and double-sided. It depends on whether you have all the DIMM socket on one side of the PCB or both sides of the PCB. I'll share a little bit more about the double-sided later on. On the I/O side, we have a PCIe by 32 through the riser. Then we can plug different kind of risers and add-on card to have different kind of configuration. The system also support 3.5-inch hard drive or the M.2 SSD as the boot drive. And on NIC-wise, we support OCP NIC 2.0 up to 100 gig. And this is a halfway system. You can see our 2 OU chassis, we can take 3 systems. So it's pretty high density for this put into the Open Rack V2. Here is the motherboard comparison in between our previous generation Leopard and Tioga Pass. On Leopard, we have a one NIC connector A that takes PCIe by A. We can support up to 50 gig NIC. And on Tioga Pass, we add another connector B, which we can support up to 100 gig NIC. We'll also add another connector C there to support Intel Chaos mass card. And as Skylake CPU takes more PCIe signal, that we're able to update the PCIe slot from by 24 to by 32. For M-SATA boot drive, we change it to M.2 SSD. As we see, M.2 SSD is a market trend. For BMC-wise, BMC now, we add one more secure flash to add on to the firmware flash. So we have 2 flash for BMC now. I'll talk a little bit detail like in later on how we use these to secure our BMC firmware. And it's an Intel Skylake processor, 6-channel per CPU. From I/O side, we'll also upgrade the LMAX connector from by 8 to by 16. Okay. So first is a double-sided DIMM. We enable this to smart our memory configurations. You may have a question that do we have a manufacturing concern? We did a lot of study about this. So the typical PCBA process that mixed pin paste process together with the wave solder for through-hole components. In this case, the DIMM on the bottom side that limited by the height, so we're not able to do the wave soldering process. And then we decided to change all the components, all the through-hole components to SMT type. In this case, we can do pure pin paste process in manufacturing side. We did multiple times PCBA build with good quantity, and it shows really reliable, and the PCBA yield rate is as good as our single-sided SKU. So lower picture shows how it looks like a motherboard that we have a DIMM on both sides. And from serviceability point of view, that we have an open area for the DIMM on the bottom side. Whenever you need to service the DIMM on the bottom side, you just flip over the chassis that you can easily repel or swap. So this is a new feature we enabled for this server. Imagine that, so if you are familiar with Intel processor, they always request to have an Intel ITP tool, the blue box. One side to connect to your laptop, the other side connect to the SUT that you want to debug with. But think about in data center, how possible you can do that. You have thousands of servers, millions of servers that you don't even know when the issue is going to happen, right? So we worked with Intel to enable this feature that have BMC to have the run control signal and a standard JTAG signal to connect to the CPU and PCH. In this case, you are able to have the BMC to access the CPU. Of course, we're going to have the Intel supported software to issue the command to BMC to do that. This is really based on you have a secured management from network. So currently, this feature has been enabled. Tioga Pass. Sure, we're going to benefit a lot from this feature. Verify Boot BMC. We all know that with Intel TXT feature, we are able to boot with a trusted BIOS firmware, but how about BMC? Unfortunately, our BMC chip doesn't support the hardware-based or CPU-based rule of trust. So we came out with this solution to add a ROM-based rule of trust. We add a secure flash here to use the secure flash to enable this feature. So the right side is the process, ROM-based, how this ROM-based flash to secure our flash. So we have a BMC firmware flash with a signature signed with a private key. And we have the hash value saved in the BMC firmware. So whenever BMC is going to boot, you will boot to the secure flash. The secure flash is with a public key that able to take out the hash value and then to decrypt that. And also, we can get the firmware from the BMC chip and also hash it. We compare these two values. If these two values match, then we go ahead to boot to the kernel. Otherwise, we're going to route to our recovery path to download or refresh or refresh the standard golden BMC firmware. And all these values are at the same time are stored to our BMC TPM that we added to this hardware that for a runtime check. OCP debug car. There are a couple of reasons why we enable the OCP debug car. First is that the original Facebook used the 14-pin debug car, which is hard to access. And then in this case, we are using the USB interface, which is pretty convenient. And also, it saves the I/O space. Most important that you see we add a small LCD panel here to show some human-readable information that which is enables the debug much convenient. Basically, we just remap the USB 3 signal to the UR signal to I2C signal and the present pin. And then the original USB port, you are still compatible with any USB 2 device. So it's user-friendly, easy to access the system, and we have a console support since we have the UR signal, console to host or console to BMC. And 7-segment postcode, the traditional debug, we still have there. At the same time, LCD contact, we actually designed couple frames that to support. When you have the postcode like B7, you will show memory initialization, or 92 is a PCIe initialization. It will tell you you don't have to go back to the menu to check what this code means. And at the same time, we also designed some other frames, for example, the system information. You may have some situation that you plug in and then you just want to check what's the IP or what's the BIOS version, BMC version. In this case, when you plug in, just plug in the debug card, it will show you the system information very easily. And also critical sensors, like I listed some of the here in the right side picture. Will tell you CPU temperature and the fan speed. Whenever there's any sensors out of the threshold, that we're gonna reverse the color that reminds you something happened to this car, then you don't have to go back to check either from in-band or out-of-band way to check the cell. There are also some other frames like the GPIO status showing the power status or the system status of this server. And then you can also enable the user setting, for example, the power policy or the boot priority. That depends on needs. We allow customize your BMC firmware, since all this information basically are from your BMC firmware. We allow you customize your BMC firmware to enable this frame by your needs. We already contribute this debug card design together with the debug card microcontroller source code to OCP, that you can get this design package and then see if it's gonna benefit you. Open BMC. Open BMC is Facebook open source firmware. BMC firmware is first time to introduce to our 2-socket server. We have a dedicated Open BMC session hosted by our BMC engineer Saeed, that you're welcome to join that session as well. All these BMC firmware we open source through GitHub. Thermal design. Before I get into these numbers, I want to get some background for our data center. In our data center, we're using natural air to cool down all these servers. There's no chiller, there's no air conditioner. So our thermal design has one more boundary, which is the CFM. We have a limited CFM to cool down thousands of servers in the data suite. So we use a CFM per watt as a metric for our thermal performance. And the CFM per watt can be correlated linearly to delta T here. So you see, for a single-sided board at 86 Fahrenheit inlet temperature, we can achieve delta T 33F. And the CM per watt is less than 0.1, which is pretty efficient. And we support the fan redundant at 95 ambient temperature. For Tioga Pass, we only have 2 fans. Whenever one of the fans fails, the other fan is able to cool down the system continuously. The fan power is only 1 to 2.5% of the combined CPU power. So we maximize the delta T for our thermal efficiency. So I would say our thermal engineer did pretty good job to optimize our thermal efficiency for Tioga Pass. The VGA port. So this is a feedback from OCP community that before we don't have a VGA port. So we take this feedback and then add the VGA connector here. But as we have a limited I/O resource, this is a half-width board. So we put a proprietary connector here that we can use the VGA adapter cable to allow you to connect to any of the monitor. Let's get into the configurations. So the front I/O side, we have a by 32 PCIe. We use high-density SAM-tag serial series connectors, two connectors here. And from that, we have a different kind of riser for our single-sided board or double-sided board. Some of the key features of the riser card I want to highlight. First one is the JTAG support. This is also a feedback from our OCP community that in order to support some of the add-in card, for example, FPGA card, they require to have the JTAG to update or access the add-in card for their own use. So we add the JTAG support, connect the JTAG signal from BMC JTAG port to the riser card. So we're able to support that kind of needs. The second feature is the host SM bus to the slot. So with this, our host is able to get some of the configuration information even before your PCIe initialization done. And then we have a 2.0 to PCIe slot as well. USB 2.0, I can give a use case is that our big basin. So our Tioga Pass is a handle for big basin. We're able to use the USB 2.0 from host connect to the big basin BMC. So we are able to do in-band firmware upgrade, which is more efficient than the traditional I2C or KCS interface. And you know, from the system, except for the CPU and memory, basically the add-on card will be most high-power components that we add the current monitor into each slot for you to monitor each of the slot, how much current, how much power it consumed. So this is the configuration. Tioga Pass can be used as a general compute server. Tioga Pass can be used as a compute server with some other add-in cards, for example, with a flash. We have an AVA card. You can take the SSD there, and then can be configured as a compute server with flash. Tioga Pass can also be used as a handle for some other PCI expansion box. So it currently used as a handle for our big basin GPU server. As a boot drive, depends on whether you care about the capacity or you care about the cost. You can choose either the hard drive or the M.2 SSD as the boot drive. And then for NIC, based on your Ethernet bandwidth needs, you can choose different kind of OCP needs. This is really the reason why we are creating modular design, that we can have flexibility to configure the system. Also, the Intel KRMS card here, you can also use it for your needs. So this is an overview about our open rack. We have a 2 power zone support up to 12.6 kilowatt per rack. And each rack, we have 8 chassis. And each chassis can take 3 Tioga Pass. So we can support up to 48 slots per system, which is really high density. On each chassis, we have a Medusa cable to do 1-to-3 split. And on the motherboard side, we have the Presby cable to connect to the chassis. All right, any question? Yeah. Okay. I will be there later on after the next presentation.